How's everybody doing this evening? Hey, we're just going to be reviewing several things before the big test tomorrow. I'm on page 9 in book 3, so take a look at page 9. Came across this problem, 3b. It says determine this equation of a line that passes through negative 6, 1 that also intersects this line 3x minus 6y equals 12. You know, when you're reading these questions, you got to read very carefully. If you do not read it carefully, you might be looking for an answer that is going to be incorrect, not the answer that they're looking for. So you must read very carefully. So the first part of the question, determine the equation of a line that passes through negative 6, 1. Okay, let's find that point, negative 6, 1. Okay, let's assign axes x and y first. Okay, x is negative 6. I see negative 6 right there. Y is 1. So we're going to mark the point negative 6, 1 right here. Okay, that also intersects 3x minus 6y equals 12. First of all, I'm just going to make it easy for myself to put it in y equals mx plus b form. You guys all know that. This is all review actually. Y equals mx, m being the slope, b being the y-intercept, right? We've gone over this numerous times already. Okay. So we have the equation 3x minus 6y equals 12. I'm just going to put it in the original y equals mx plus b form that we can easily graph off of. Okay, so I'm gonna subtract 3x to both sides. I'm gonna divide by negative 6 to both sides. Negative 3 divided by negative 6 is going to be 1/2. 12 divided by negative 6 is going to be negative 2. So I get it in the form y equals 1/2 minus 2, which is exactly in the same y equals mx plus b form. That is what we were originally trying to achieve. Okay, let's find that point. So we know the y-intercept is at negative 2, which is here. This is the y-axis. Y-intercept is here. Now I have 2 points already. 2 points already on that line. Wait a minute. Let's back up a little bit. Sorry. Let's graph this line first. Y-intercept is negative 2. What is the slope? Slope is 1/2. That means for every unit I go up 1, then I go 2 to the right. Okay? That's what it means. 1 up, 2 to the right. 1 up, 2 to the right. Here's another point. So let me just draw that line right there. Sort of. Okay. It'll be something like this. Close to that. Okay. This is this line. Y equals 1/2 x minus 2. Okay. Now, what is the original question? Determine the equation of the line that passes through negative 6, 1, passes through that point, and also intersects this line here. Okay, could be any line as long as it's not parallel to this line. So right off, I see that here's a line that's simple for me to see right here. Watch this. Now you guys can have different lines, but this is one that I'm going to select right now because it's so simple. Okay, it intersects this y equals 1/2 x minus 2 at 6, positive 1. Over here is a negative 6, 1. Anyway, I think that's a little coincidence there. But you see there is an intersection point here. That intersection point is what we call the solution to the two equations, the system of equations. That is your solution. It intersects right there. So the question is, determine the equation of a line that passes through negative 6, 1, that also intersects this line right here that we just graphed. It does intersect it right there. So what is the equation of the line? Well, it has no slope. It's a horizontal line. It has no slope. So your m is 0. You don't have that. All what you have is a y-intercept, which is that. The y-intercept is 1. Okay? So the equation is y equals 1. Y equals 1. Y equals 1. This is y equals 1. Okay? It's as simple as that. Okay? That is my example. You can come up with your own examples. Y equals 3. Y equals 10. Or you could come up with a line that's going like that, with a negative slope. It's pretty much up to you. Anyway, for my example, here's another question. What is the point of intersection? Point of intersection is 6, 1. And that is just because I chose the line y equals 1 to intersect this line here. Okay? Hope you guys got it. Take a look at that. If it's confusing, just keep trying to, maybe you can come up with your own line and see if it makes more sense, okay? Now, in these workbooks, they don't have too much discussion, but in this particular case, they go over this area called the system. The collection of two or more lines is called a system of linear equations, or more generally, a system of equations, including perhaps nonlinear equations in two or more variables. A system is often described informally as having two equations with two unknown values. Okay? A solution to the system is the coordinates of a point or set of points that satisfy each equation in the system simultaneously. The solution to a system will be ordered pairs x, y, and this point will lie on both lines, which is the point of intersection. Substituting the coordinates of the ordered pair into both equations of the system must result in true statements. So the x and y will satisfy both equations at the same time. If no such point exists, then the system is said to have no solution. Okay? Now let's see, what else can we go over that I know you guys are going to have a good grasp on. Let's see. You guys probably did all of this already, right? I'm just looking at what you're gonna have to go over. Okay, let's try this example right here. Let's try this. It says solve the system of equations below using the graphical method. Okay, let's try that. Okay. Okay. For the first one, if x equals 0, let's label our axes. If x equals 0, then what is y equal to? Y is going to be equal to 3. If x equals 0, y equals 3. Okay? So I'm going to call this 0, 3. For the first one, if x equals 0, 2y equals 6, that means y equals 3. Okay? What if I say if y equals 0, then x would equal 6. So if y equals 0, x will equal 6. 1, 2, 3, 4, 5, 6. Okay? And that point is 6, 0. Okay? I can draw a line through that now. Something like this. Something like that, okay? How about the next equation? The next equation has to be true also if we are to find a solution. So, for example, now this is in y equals mx plus b form. So this will be an easy way to do it. -1 would be the y-intercept. -1 right there. And 1/2 is our slope. So I go up 1, 2 across. Okay. And if I go up 1, 2 across again. Okay. So let me draw the solution. Do you guys see how long I take to actually draw the lines as accurate as I can make it? Okay? And I use a straight edge. See, all of this is important if you want to solve the solution, solve the system of equation using the graphical method. Well, I can see just by my eyeball that that point there is our solution to the two equations, to the system of equations. And what is that point? Let's count. 1, 2, 3, 4. 4 and 1 up. The coordinate of that point is 4, 1. Okay? So this is one example of using the graphical method to finding a solution. Okay? Remember the graphical method right there. We're going to go over 3 different methods to finding the solutions. This is the graphical method. The next one is going to be through substitution. Now on page 14, there's a whole explanation there on how to do this. Page 14, okay? I'm not going to go over that right now. I'm just going to go and do a couple of examples. Probably we may have done some of these in class, but let's try a couple of them. Okay, I'm going to try C. This is by the method of substitution. Okay, so remember, a few pages back, a system of linear equations, two equations and two unknown values, just like this right here. Two equations with two unknown values, y and x. All right? So let's solve the system of equations using the substitution method. Okay. Okay, pay attention, guys. Come on. You guys can do it. Don't fall asleep. Come on. Okay, here's y, and here's y. Now, what I can do right here is substitute one of these forms of y into the y of the other equation, and I can solve for x. Okay? Remember, if y is something, that means this whole thing is equal to this whole thing, because both of them are y values. They're actually equal to each other. Do you guys see that? If this is y and this is y, they're equal to each other. Okay? So let's use the substitution method. I'm going to use the second value of y and make it equal to the first value of y. So this is how I am going to write it. Negative x plus 7 equals 4x minus 3. Did you see what I just did? I just brought this value of the second equation of y, substituted into the first equation of y, and made it equal to that value, 4x minus 3. Now I can solve for x. So let's solve for x. If I bring the 4x over to this side, I'll minus 4x to both sides. I will end up with minus 5x on this side. The 4x goes away because I just minus 4x to both sides. I'm going to minus 7 to both sides. I'll have on this side minus 10. Minus 3 minus 7 equals minus 10. And remember, when I say minus 10, it could also mean negative 10. I use those two terms, minus and negative, interchangeably. All right, just to speed things up. Okay, here we go again. I have negative sign here, negative sign here. I'm just going to cancel them out both by multiplying negative 1 to both sides of the equation. I'm just going to call that plus plus. I mean, algebra is a beautiful thing if you know how to use it, right? I'm going to divide both sides by 5, which will leave me x equals 2. Once I know x equals 2, I can substitute it back into one of these original equations right here. I could substitute it right there into the first one. This is a value of x, and this is x right here, which is the same thing. So I can just substitute this, stick it right in there. Let's write it out. I'm going to write it up here since I don't have space down here, okay? X equals 2. So in this equation here, the first one, y equals 4, I can substitute the value of 2 because x equals 2 here. Okay, I'll just substitute it 2 into the value of x right there, minus 3. And simplify. 8 minus 3 is 5. So right there I have the x value and the y value. Okay, see how that is? So this is where the two lines intersect. We call it a solution to the system of equations. X value is 2, y value is 5. Just like that. Okay. How about we do another example? How about we do D? Okay. Okay, we're going to use the substitution method again. Okay, let's get going. I don't want you to be here all night. Okay. Okay, look, x equals something here, which makes it perfect for using the substitution method, because I can take this entire value of x and substitute it right there, right here. This entire value will go right there because it says x there. It's the same x, okay? It's the same thing. So let's go for it. I have 6 from here, x, and this is also x. So we substituted that entire value like this, which is the x portion, minus y equals minus 1. Okay. Now we have only one variable here, so we can solve for that variable. The variable is y. Let's use the distributive property and break this parentheses up. Okay. 6 times 1/3 y is 2y. 6 times -1 is -6. And then I have the negative y here equals -1. Combining like terms, 2y minus y equals 1y. Okay, it's 1y equals. Now, over here I have a -1, and on this side I have a -6. I'm going to add 6 to both sides, and when I do that, this goes away. Add 6 to this side, I'm going to be left with y equals 5. Okay. Now I have the value for one of our coordinate values right there. Now what is the other one? We're going to have to find out what x equals. Let's do that. Now because I know the value of y equals 5, I could substitute it right into maybe this one, because I have the value x equals 1/3 y minus 1. It'll make it simple for me to calculate. Okay, let's do that. I'm going to go up here. X equals 1/3. Now the y value, I can substitute the 5. Let's do that. Minus 1. Okay. So what does that equal? 5/3 minus 1. Okay. What else can we call that? 5/3 is also 1 2/3. 1 2/3. Okay, minus 1. 1 2/3 minus 1 equals just 2/3. That is equal to 2/3. So x equals 2/3. Okay. Sorry. Okay. So our solution here would be 2/3, comma 5. Okay. just like that. I hope you guys are getting it. Let's move on. I don't want to stay here all night, and I know you want to go to bed too. But there's the third way. It's called the elimination method to solve a system of equations. On page 19, you have the whole description right here. I'm not going to go over it. Page 20, there's another description. Page 21, there's another example. But I am going over one more example, or maybe two more examples of the elimination method. Okay, let's do this. It'll be quick because it's so simple. Here's number 4. Elimination method, we get the two equations and we're going to manipulate them, and then we're going to either add them or subtract them from each other. Remember, manipulate them so it's easy to add and subtract from each other. And when we're doing that, we're trying to eliminate one of the variables so we can solve for the other variable. If you see here, you have 2x. You have 2x. Now if I subtract this equation from this equation, I can get rid of that 2x. So let's do that. Subtract that whole thing like this. Okay? I can do that. This is why algebra is so cool, guys. Come on. 2x minus 2x is 0, so that x's go away right away. I'm going to be left with 4y minus 9y. I'm going to be left with minus 5y. I'm going to have 6 minus 16. 6 minus 16. Minus 10. Negative and negative on both sides. Here we go. Y equals 2. Y equals 2, so what is x? I just substituted back into one of these original equations. I can use the first one. I'll have 2x plus 4. Now it says y, 4y, and instead of using y, of course, what I want to do is use the actual value of y, and I'm going to substitute that in for y, the 2 value for y equals 6. Let's manipulate this again. I'll subtract 8 from both sides. Okay. I'm going to have x equals negative 1. So here's your x value, here's your y value. Your solution coordinate is going to be negative 1, 2. Okay? Hope you got that. Okay, let's try 6. 6 is a little bit trickier, so let's try that one. Okay? I think that's a good example. Let's work on that. It'll take a little bit of work, but it's just doing it step by step. Nothing fancy. Step by step, and we can get the right answer. It's not complicated. But you got to keep track of all your work. You got to know exactly what's going on. You cannot be messy. If you be messy, you're going to get confused. You're going to mix up and mismatch the values, and I don't want that to happen, okay? You got 2 variables, 2 unknowns that you need to solve, which is no problem because you have 2 equations to help you solve that. Let's get to it. We're going to use the elimination method. This time it's the elimination method, right? Okay. This is page 22 again. So for 6, it's a little bit harder than 4. It's not that hard. Okay. So I'm going to use the negative 3y and the negative 2y. The next common multiple would be 6. So that's what I'm going to do. If I go here, if I use these x values, then the next common multiple would be, I think, 24. So that's too large of a number. I don't want to do that. I'm going to work with simple, small numbers if possible. So here we go. I'm going to call this, let me just do it like this. Call this equation 1, equation 2, just to keep things all in order. Okay, I don't want to get confused. So the next multiple between 3 and 2 is 6. I can get the negative 3 times 2 is negative 6. And the negative 2 times 3 equals negative 6. Okay? So I want to be able to subtract one equation from the other and eliminate a variable. That's what we're going to do right now. Okay, let's do that. Okay, so the first one, let me write it down here. I'm going to multiply that by 2. The whole thing I'll multiply by 2. Okay. Now this is equation 1 still. We're just manipulating the equations. That's all we're doing. 2 times 8x is 16x. 2 times negative 3y equals negative 6y. 2 times 3 is 6. I just did a multiplication to both sides of the equation. That's all I did. Okay? Now the key here is I have a negative 6y. Okay? Now here, the second equation, here, 3x minus 2y equals negative 5. I'm going to manipulate that. Okay? I'm going to manipulate. Multiply the entire thing by 3. And you'll see why I do that. The whole thing I'm going to multiply by 3. Okay? I'm not changing the value of the equation. I'm just manipulating the coefficients. That's all. 3 times 3x, 9x. 3 times negative 2y, negative 6y. 3 times negative 5 is negative 15. Okay. Now I want you to pay attention to the two manipulated equations. This and this. Now I have this negative 6y, I have a negative 6y. If I subtract them, subtract those two equations from each other, one from the other, I can get rid of one variable. So let's do that. Pay attention. I'm going to subtract this from that. Okay. Boom. Right there. This subtracted by this. 16y minus 9, 16x minus 9x, sorry, is 7x. Negative 6y will be plus a 6y. That goes away. completely, which is the whole reason why we set it up like that. 6 plus 15. I get two negatives there, so it's going to be 6 plus 15 is 21, which leaves us with x equals 3. If x equals 3, I can find out what y is by substituting the 3 back into one of these original equations. Okay. I can use the second one. Let's try. Let's try the second one. Okay, so let me just call this equation 2 again. Okay. 3, here's the x equals 3. I'm going to substitute 3 into the value of x right there. Okay. X is 3. I just substitute it right into that spot right there, which is 3 minus 2y equals negative 5. Okay. Now I can solve for y here. Okay, I have 9 here. I'm going to subtract 9 to both sides. When I do that, minus 9, negative 5 minus 9, negative 14. I come up with y equals 7. So the solution to your system is going to be the coordinate 3, 7. If I didn't make any silly addition or subtraction errors, this is going to be the answer, okay? The main thing is I want you to understand why we do what we do. And I hope you got it. Okay. Let's just go over it again. Elimination method. We got two equations. We just numbered it, one and number 1, number 2. So the first one, we're going to manipulate that equation by multiplying it by 2. There's your 2. And turn that negative 3y into 6y. Negative 6y. Okay? Now the second equation is right here. We're going to manipulate that second equation by multiplying by 3. Okay? Right there. We're going to have an answer like this. And we're going to subtract this equation from this equation. Subtract it. 16x minus 9x equals 7x. Negative 6y minus 6y, that goes away. 6 minus a minus 15 is like a 6 plus a 15, which is 21. Get the x equals 3. Once we get the value of 3, substitute it back into one of the original equations, doesn't matter which one. I chose to use the second one in this case. So that value of x, which is 3, I just substituted in for the variable right there. So 3 times 3, okay, then the minus 2y, just drop that down here, equals negative 5. I'm using the second equation to solve for y. So the 9 minus 2y equals negative 5. I'll subtract 9 to both sides. That'll give me negative 2y equals negative 14, right? Value of y is 7. So this is the solution to our system of equations, okay? That's it. Okay, guys, I believe you should be ready for the exam tomorrow. Uh, please keep up with all the work every single day, 1 hour a day at a minimum. If you're falling behind, 2 hours a day. If you're studying for a big test, maybe 3 hours before the test. You got to put in the time. I guarantee it will show up in your grade. There's no easy way around it. You got to put in the time. If you're struggling, network with another friend. Go over the videos over and over. Go over the examples that I give you guys in class over and over. And do the workbook. Finish up the workbook. Spend time in the workbook. If you need more information, look up Khan Academy and look at their videos as well, okay? I mean, you got the whole internet at your fingertips now. You can be as good as you want. It's just a matter of a choice that you have to make. Okay, guys, good luck. I'll see you tomorrow. And please review the videos over and over again. Okay. Have a good evening. Good night.